Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to talk about self-hosting in the smart home. So the home automation industry has actually been around a lot longer than you think. I first remember the clapper in the mid-1980s that used to turn lights off and on. And then I first used X10 lamp modules and X10 light switches in around 1985, and X10 is still in use today. And in fact, what's kind of surprising is X10 was invented in the mid-70s. So most current DIY home automation uses either Zigbee, Z-Wave, Wi-Fi, or Bluetooth low energy protocols. Common home automation hubs are Samsung SmartThings, which is now made by AOTech, Apple HomePods, Amazon Echo Show 10, Google Nest Hub 2nd generation, and Habitat Elevation. Control 4 is also a professional alternative to these other DIY solutions. So, self-hosted home automation is usually referred to when we think about products like OpenHab, which was brought online around 2010, and it's a software-based home automation hub that is developed in Java and is well established and stable. And then Home Assistant, which was developed in 2013, is another open source software hub developed in Python and has a friendlier UI and seems more innovative. And these solutions you generally run on your own hardware, and you can even run them on things as small as a Raspberry Pi. So both of these are great solutions, as well as many of the hubs that I mentioned previously. I personally use the Habitat Elevation as my hub, but I'm not going to focus on the hub as much as why powerful home automation might need self-hosted functionality on your home lab. So why would I need more automation? Well, any of the DIY home automation solutions mentioned can turn devices on and off and monitor the readings from basic sensors. A good smart home has smart switches, outlets, locks, HVAC controls, garage doors, and motorized blinds and or windows, and even more. But in addition, smart sensors to monitor temperature, humidity, light, motion, vibration, open-close status, leaks, air quality, and water flow are also very helpful. Automations using hubs are usually quite comprehensive. Sometimes supplemental processing is needed on the LAN or in the cloud to expand the functionality of a hub. So, what do I need in order to automate? Well, the answer to this is going to be different depending upon your requirements. I have a Habitat Elevation, which I mentioned earlier, which I choose to control everything else. And that's an important point. If you choose a hub, you want to make sure that hub is the center of everything. It can get very confusing if, say, you have a Google Home Hub and you have it control some things, and you have an Amazon Echo Hub and it controls other things, because you can't remember where your automations are or what is controlling what. So I have a lot of devices. I have Amazon Echo devices, I have Google Nest Mini devices, a Philips Hue hub, a Bond hub, a Chamberlain MyQ garage door bridge, a Nest thermostat, Nest smoke detectors, a Daikin mini split air conditioning unit. I have several Sonos speakers. I have Android tablets. I have Reolink power over Ethernet cameras. I have Unify Protect cameras. I have Fire TV 4Ks. I have Roku's, smart TVs, Silicone Dust Network-based HD Home Run 4K tuner, an UMA hub for phone, Google Chromecast, a couple of Obihai VoIP phone adapters, a Rachio sprinkler controller, and Ubiquiti Unify network infrastructure. And these are just some of the things that I control through my home automation. So we're going to take a look about my use of home or self-hosted applications to drive automation on some of the devices listed above. So hubs can't do it all. Local control is great, but sometimes an application needs to live in the cloud. As an example, I use a Monocle website and associated skill and Google Smart Home device management SDM API, and I also use Echo Speaks, which uses the Heroku platform as a service. So local hosting is needed for several functions on my network, and here's some examples. I use the Cast All the Things server, CAT server for short, which is a Linux controller that can remotely display web pages on a Google Chrome device. My Harmony API is a Docker image running on my LAN that provides device-level control of my Harmony hubs, and I have 3 Harmony hubs. My camera image web server is a web instance on my LAN that records motion events from cameras as a group of frames. And Monocle Gateway is a LAN-based RTSP to RTP gateway to convert camera streams to a format that Amazon Echo Show and Fire TV sticks can display via voice commands. And then I have something called Public IP Proxy, and it's a local LAN server that runs PHP code to provide feedback for internet connectivity. And then finally, I have something called Xfinity Data Usage, and it's a LAN server that extracts information from the Xfinity API on internet account usage tracking. So, first of all, the CAT server and Harmony API. I typically watch either the live TV tuner on my TV, my Fire TV 4K Max, or my Roku, and even some other sources I haven't mentioned. I voice command these video sources from my Amazon Echo, which uses the Harmony Hub skill for the Echo. Harmony Hub control from the Amazon Echo can only start and stop skills and control volume, and it can do some simple things like pause and resume. I use a Habitat application called Cat Director, which sends a web page URL to my Cat server instance, which directs my Google Chromecast to display a URL. When the Chromecast is awakened, it sends an HDMI CEC, and for those of you that don't know, CEC stands for Consumer Electronics Control Signal, to the TV, and that switches to the Chromecast HDMI input when it sees activity on the Chromecast. As an example, the voice command EXA, show me the radar, turns on a virtual switch named display radar on TV, and that tells the Cat Director to send the URL to the Cat server, which then contacts the Google Chrome device and displays the web page for the radar. Since the Harmony Hub does not know that HDMI CEC switched the input away from the input I was watching, I created a voice command, EXA return, which turns on a switch that triggers a web core piston from Habitat that changes the HDMI input back to whatever input was being used by the current Harmony Hub activity by making a call to the Habitat Harmony app, which triggers the Harmony API Docker instance running on my LAN to reset the HDMI input back to where it should be. I can also cast to the Chromecast with a phone, tablet, or laptop, and HDMI CEC will switch to the Chromecast, and when I'm done, the EXA return command puts the HDMI input back to what I was watching. EXA, show me the radar. EXA, return. So then I also have a tablet display with a product called Fully Kiosk. The Fully Kiosk browser at the URL listed is an Android browser that can be remote controlled. I use voice commands such as EXA, show me the tablet, or show me the dashboard in the bathroom, which turns on a virtual switch. The virtual switch uses a Habitat application called Fully Kiosk Director to send a specified web page to the tablet to be displayed. This provides the functionality that I get with the Cat Director on the Google Chromecast with ordinary Android tablets with the Fully Kiosk browser installed. Master bathroom here with a Sonos speaker on the top. And then I have an in-wall tablet here, which is just a Samsung tablet. Alexa, show me the dashboard in the bathroom. So this uses Fully Kiosk browser to display this Habitat dashboard. Then I have my camera image web server. I have a web server with PHP installed with code that receives and stores images to it that can be historically reviewed. Whenever a Hue outdoor motion detector on my front porch sees motion, the Echo in the family room reports that someone is at the front door. A Habitat custom device of type camera motion capture has a rules machine rule which performs an event capture which takes 6 frame snapshots 1 second apart and stores them to the web server interface. When everyone is away from home, a snapshot of the front door and the driveway are emailed to my wife and I. A voice command, EXA, show me the front porch, uses the Cat server to replay the 6 frames of video recorded to the web server. Show me the front porch. So return. Then I have the Monocle Gateway server. I have several Reolink RLC 520 PoE cameras and a few Ubiquiti Unify Protect cameras that record video 24/7. The RLC 520 camera is not natively supported by Amazon, and neither are the Unify Protect cameras. The Reolink Skill for the Amazon Echo devices only supports the low-resolution RTSP substream. The Monocle portal at the URL listed and the Amazon Monocle Skill together allow access to cameras not natively supported by Amazon. The Monocle Gateway server instance hosted on my IoT VLAN converts the Reolink and Unify Protect high-resolution camera streams to something that the Echo Show and the Fire TV 4K can display with a voice command. If I'm watching an HDMI source other than the Fire TV stick on the TV, the HDMI CEC switches the input and the EXA return command resets the input as demonstrated earlier. So, show me the driveway.
Okay.
So, return. Then I have a computer room habitat dashboard. This is what that dashboard looks like, and it has quite a bit of valuable information on it. The computer room dashboard displays ambient and rack temperature. The dashboard displays if the rack is opened or closed with the use of a contact sensor. My Xfinity has a data cap of 1.2 terabytes, and so I have an Xfinity API server instance that queries data usage, and I estimate the monthly total usage of data. Internet status is displayed with the current WAN address. And last internet outage is determined by a ping process that runs to monitor remote access. Last power outage and power metrics are retrieved and calculated with a NUT driver, which is otherwise known as a Network UPS Tools driver on the habitat, which accesses the NUT interface on my QNAP NAS systems. Then I also use an application called Echo Speaks. Echo Speaks is an Amazon Exa voice skill that can provide advanced voice responses on an Amazon Echo device. Echo Speaks, and there's the URL for the documentation so you can learn a little bit about it, was originally developed by Anthony Santilli for use with Samsung SmartThings, and it's now available on Habitat. So when Tony developed this application, it was originally for the SmartThings app only, and then later when SmartThings went to their new generation, they disallowed apps like Echo Speaks. So now Echo Speaks is a major application used for this type of capability on a Habitat elevation hub. So Echo Speaks code runs on the Habitat and accesses a platform as a service instance of Heroku in the cloud and communicates back to Amazon. I have a lot of web core pistons that use Echo Speaks for complex responses. And Echo Speaks supports many advanced and music features and can even be used to arm and disarm Exa Guard automatically when Habitat Safety Monitor arms in away mode. Give me a security report.
The security system is currently disarmed and has been that way since April 15th at 10:16 a.m. The last time everyone left the house was April 14th at 5:04 p.m. and you were last gone for 2 hours and 8 minutes. You last returned on April 14th at 7:13 p.m. Right now Scott's phone is present and Kat's phone is present.
So, in summary, typical home automations that may turn a light on when motion is detected are easy to implement with the most basic hub. Sometimes applications like those I've shown require either more complex code or access to cloud and or land-based additional servers. I use a Habitat Elevation Hub supplemented with WebCore for many of my automations. Self-hosted application instances in Docker, LXD, and virtual machines can provide important supplemental processing to expand your home automation. And I have several videos on my channel that discuss how these containers can be used to implement many self-hosted applications. Anyway, that's it for today. Please subscribe and like to the channel, and we'll see you next time.